Hello guys, Anish PyMasters College here. So today we'll be going over the data structure of 2D lists. So in the last video we talked about lists. Lists are basically just a collection of objects that can be indexed. A 2D list is basically a list where its elements are just other lists. So instead of a list of like integers or strings or floating point numbers like decimal numbers or booleans, now the elements are just other lists, and those lists contain they could contain, like primitive types like integers or strings. So, for example, we have this 2D list right here. This 2D list is just a single list right here denoted by these larger square brackets, and then the elements of this list are just other lists. Now, like we see here, we have this list right here, this list, and this list. So these lists are just elements of the outer list. And just like elements of a list, they can be accessed by their index. So you see here, this first list is the first element of the overall list. So that's why it has an index of 0. The second list has an index of 1. The third list has an index of 2. And then inside of each list, we have elements. We have integers in this case. So in this list, this first integer in the first list has an index of 0. The second element has an index of 1. The third element has an index of 2. But in the overall, if we wanted to access this element from like the perspective of the outer list, we would first have to access this list, and then we have to access the element. So if we wanted to access the 6, what we would do is, let's say this list was called list. So we do list square brackets, and then we want to access the list that the 6 is in, and then that list is index 0 in the outer list because it's the first element. And then within list at index 0, or within the first list, 6 relative to that first list is index 0 because it's the first element of that inner list. So you want to access the outer list first and then the inner list, and then that gives 6. So if I had, for example, list square brackets 1 square brackets 2, what would be returned here? So we're doing list square brackets 1, which should give us this list. And then that list square brackets 2 should give us what, the third value in that list, which is just 3. So that's basically just how indexing works, how you access elements in a 2D list. Um, Now, if we also wanted to think of lists in a better way, we can think of them as rows and columns. So we can think of 2D lists as a grid, and a grid obviously has both rows and columns. So for example, each row it usually represents the inner list, and then each column usually represents the indices of the elements within each of those inner lists. So for example, the rows would represent these list elements here inside of the larger list. So for example, we'd have 6, 4, 7. The next row would consist of the second list, 1, 2, 3. The next row would consist of this last list here, which is 8, 11, 13. And then so the indices of these rows, obviously this first row here represents this first list, which has an index of 0 relative to the outer list. The second row has an index of 1. The third row has an index of 2. And then within each row, we obviously have these columns right here. The first column represents the indices of the first element in each of those inner lists, right? Or the first element in each of the rows, which it has an index of 0. Second column has an index of 1. Third column has an index of 2. So now if we did, for example, list square brackets 2 square brackets 1, this first number in the square brackets always represents the rows, the second number always represents the columns, and that is simply because when you do list square brackets 2, you're first accessing the inner list, and then when you do that inner list square brackets, another index, you're accessing the element within that inner list. So list square brackets 2 just gives us the row with index 2, which is just the third row, which just pertains to this list right here, or the last list, and then that list square brackets 1 just pertains to the second element, or column 2 or column index 1, and then so that would just give us 11. Row 2, column 1. So rows are just the lists, columns represent the individual elements within that list. So another example, let's say we wanted 7 printed, we would do list square bracket 7's a row, which is 0, index 0, and then it's column, which is index 2, and that would give us 7. And then that works because list at index 0 represents this first inner list right here. That list at index 2 represents the third element in that list, which is just 7. So this right here, this code is the actual implementation in Python of that 2D list we were just talking about right here. So we have the outer list, and inside the outer list, we have these elements, which are the inner lists, and then these inner lists obviously have their own elements, which are the integer values that make up this 2D list. So if we wanted to traverse the 2D list, so if we wanted to print out the list, for example, so this is what we would get. We wouldn't actually get a grid yet. If we wanted to print out like a grid, like we do here, what we could do in that case is we have to first of all traverse through each of the rows, and there's multiple ways that you can do this using for loops or while loops, but for loops are usually recommended for traversing over 2D lists. Is first you can obviously traverse over their indices, so over the index of each element using a for in range loop. So that's what we're going to do. We're going to first traverse over the rows, and then you're going to traverse over the columns. So yes, you do need a nested loop here. Basically, you need a for loop inside of another for loop. The outer for loop goes through the rows or each of these individual inner lists, and then the second loop goes through each element within each inner list. So we want to traverse over the indices of each inner list. And the way that we do that is we could say for row in range. The first row has an index of 0, and then we want to go up to how many elements there are, because how many elements there are in this 2D list gives us how many rows there are, because each row or each inner list counts as an element. That's how lists work. So if we're only traversing over the rows right now, the amount of rows there are, we have to traverse through the amount of rows there are relative to the length of the list, because the length of the list gives us how many rows there are. Because the length of this list is considered 3, so if we were to print out the length of this list, we would get 3. Um, and then so that's 3, and then there's also 3 rows. There's 3 inner lists. That's why we want to go from 0 to the length of the list. So len list 2D. And then now we want to go through the column of each of those rows. And in order to traverse through the indices of the columns, we want to go through, where we want to traverse from 0 to the length of that inner list, because how many columns there are depends on the length of the inner list. So now for call in range 0, and then the length of that row, which we would just say list 2D at row, which gives us that inner list. So list 2D at row gives us the inner list, and we don't even actually need these zeros here, because by default it already assumes 0. And then we would print out each the uh, the item at each row and column. So list 2D at row at call, and we want to print each row. All the elements should be on the same line, obviously. So end, we'll add an end property here, and that's just equal to a space. So we print a space after we print each character or each element. And then after we print an entire row, that's when we want to make a new line, so we'll have an empty print statement there. So we're getting an error here. Okay, so I just forgot to add the length, because we're traversing through the length of the row. Obviously, that's why I'm getting the error right there. So now you see it's printed in a grid pattern. So you have the rows, and then you have the columns. The rows are just the inner list, so just like how we have 6, 4, 7, 1, 2, 3, 8, 11, 13, we have that same uh, we have that same visual here. And then the other way to traverse through a 2D list is you can use an enhanced for loop or a for each loop, where you basically instead of traversing through the index of each inner list and then each element, you can just traverse through the inner list itself and then each element of that inner list. So that would also take a nested loop approach. So you could say for row in list 2D. So that would traverse through every element in list 2D, which is going to consist of these rows. So it's going to traverse through these rows directly, and it's going to assign that in this temporary variable row. And then we want to traverse through each element in those rows. So we can say for call in row. So we're going for each row, we're going through each element or each column within that row. And we're going to print the call in this case. We're not printing we're not printing, square brackets row, square brackets call, because we're not traversing through the index. We're just traversing through the elements directly. So we just print the element directly. So we're going to print call, and then at the end, we're going to have an end equals with a space to make sure that we add a space whenever we print the value. And then after we finish printing that row, we're going to make a new line for the next row. And then the same thing would happen there. And then the last thing is, let's say that you wanted to print this list we want to print the 2D list in reverse. Let's say we wanted to print, we want to keep the order of the rows the same, but we want to print each row in reverse. So instead of printing 6, 4, 7, we want to print 7, 4, 6. Instead of printing 1, 2, 3, we want to print 3, 2, 1. So in this case, you do need to traverse through the indices of the columns, but not necessarily the rows. So the rows you could traverse through using for each loop. So for row in list 2D. Now you want to traverse through the column of each of those rows. Instead of traversing from 1 to the length of the inner list, now you want to traverse from the last element to 0. Or the last element of each inner list would just be the length of the inner list minus 1. So for call in range, and then the length of each inner list, so length of the row, we're going to 0, which means we're going up to by excluding -1. And then our index is changing by -1 because we're going from the length to -1 here. So I forgot to add -1 right there, -1. So because the last index would just be the length of the row or the length of the inner list -1. And then we're going to print the element, which is just going to be row at call in this case, because row is each inner list, call is each index. So we want to do row square brackets and then add the row's index, which is the column, and then add an end equals. And after we print the row, print, and then now you see how it would be printed backwards, just like that.